find the area of the region bounded by the curves y is equal to sine of x and y is equal to cosine of x between negative pi and pi. So the first thing that we should notice when we are doing this is that the area to the left side or the negative side of the y-axis and to the right or positive side of the y-axis is the same. So in other words, this area is the same as this area. So what that allows us to do is to solve for either one of these areas and multiply it by 2 to find the entire area. Okay, so let's use this right-hand side, or the positive, or the side that's on the positive x-axis. So we also notice that we have this point here, where one graph changes from being below the other graph to being above the other graph. So it's where sine of x goes from being below cosine of x to being above cosine of x. And the reason why that's important is because then we have to change what's inside our integral. And I'll show you what I mean. But first, let's find out what this point actually is. So the point is where sine of x is equal to cosine of x. So that's the same as saying where sine of x divided by cosine of x is equal to 1. And that's the same as saying where tan of x is equal to 1. And that's where x is equal to 45 degrees or pi by 4 radians. Okay, so therefore we know that that is correct. It's pi by 4. Okay, so now we first do our integral from 0 to pi by 4. So in our area divided by 2, because we're only doing half the area, only doing that section, is equal to the integral from 0 to pi by 4 of now the graph that's above, which is cosine of x, subtracted by the graph which is below, which is sine of x, and that's added to the integral from pi by 4 to pi. So this integral here is solving for this area, and this integral that I'm about to write will solve for this area. So for this area over here, our top graph is sine of x. So we have sine of x now, subtracted by our bottom graph, which is cosine of x. Okay, so now solving for our area, or for half our area, we can solve these integrals. So the integral of cosine of x is sine of x, and the integral of negative sine of x is cosine of x. And of course, we can check that by doing the derivative of what's inside here. So the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. And that's plus, now we have to do this integral. So the integral of sine of x is negative cosine of x, and the integral of negative cosine of x is negative sine of x. And that is from pi by 4 to pi. And of course, we can check it by going backwards. So the derivative of negative cosine of x is sine of x, and the derivative of negative sine of x is negative cosine of x. Okay. Now continuing, sine of pi by 4 is equal to root 2 over 2 plus cosine of pi by 4, which is also root 2 over 2. And that we subtract from that, substituting now in 0, sine of 0, which is 0, plus cosine of 0, which is 1. So we are subtracting 1. And then to simplify this, it's just equal to root 2. So we have root 2 minus 1. Okay. Now we solve this side of the equation. So substituting in pi into negative cosine of x and negative sine of x, we get the following. So negative cosine of x, or negative cosine of pi, is, so we follow our cosine graph, and it's at pi. So cosine of pi is equal to negative 1. So negative cosine of pi must equal to negative 1. I mean positive 1, because negative 1 times by negative is positive. Okay. Then negative sine of x, or negative sine of pi, is going to be equal to 0. Okay. So we can then get rid of that, which will just leave us with 1. Okay. Now we subtract when we substitute in pi by 4. So pi by 4 into cosine of x. So cosine of pi by 4 is root 2 over 2. So it's then negative root 2 over 2. And sine of pi by 4 is also root 2 over 2, but it had a negative. So it's negative root 2 over 2. So minus root 2 over 2 minus root 2 over 2 is simply minus root 2. And then negative root 2 times by this negative out here makes it positive. So we have plus root 2. Okay, so now we can take away these brackets, and what we're left with is a negative 1 plus 1, which will both cancel out, and then root 2 plus root 2. So we'll have 2 root 2. So the area divided by 2 is equal to 2 root 2. So therefore the whole area must equal to 4 root 2. And that's units squared. Thank you for watching, and I hope you found this video useful.